In this experiment, you are going to learn how to measure a resistance and test Ohm's law. For this purpose, we collected the raw data. So, regardless of your discipline, challenging and rewarding part of your work will be analyzing the data. To measure a resistance, we used a simple resistor and set up a DC circuit including that resistor. There was a power supply in that circuit. We used an ammeter to measure the current flowing the circuit and a multimeter to measure the potential difference across the terminals of the resistor. When we set up the circuit, we connected the plus terminal of the power supply to the red slot. Since on that board, slots lying on colored lines are interconnected, we connected the ammeter in series with the one end of the resistor. Then, using the green slots, we connected the minus terminal of the power supply to the other end of the resistor. So we constructed the circuit, which consists of only one main branch, and we connected the multimeter in parallel with the resistor and adjusted the multimeter in 20-volt range to measure the voltages. When we turn on the power supply and adjusted an arbitrary output, there was a potential difference between the terminals of the resistor. That potential difference and current flowing through the resistor were measured using the multimeter and ammeter respectively. Since the aim was find out relation between the voltage change and the current change in the simple circuit, we increased the voltages from that knob to see how the current would change. And so we took voltage and current measurements for different output voltages of the supply. Now, we are going to share this data set with you as tracker file. You can open this file using tracker software. If the tracker software is not installed on your computer, you can download and install it for free. When you open the file, you will come across with two different displays. On the displays, you will see what the value of the voltage through the terminals of the resistor is and what the value of the current flowing through the resistor is. Let me open a file as an example for you. This is just an example to show you how to use your files. You should use your own files when preparing your reports, not the one given as an example. Read and record the reading values V1 and I1 by multimeter and ammeter respectively. Then fill the values While recording, don't forget the uncertainty values of these measurements. For this one, uncertainty value 0.01, and this one is 10, the smallest division, or 5. And also, we have to put the units over here. Voltage or potential difference unit is volts, and current units is microamperes. Volts and microamperes. Please be careful with the units because they are really important to reach the correct results. Click the Step Forward button and record the values read on the multimeter and ammeter V2 and I2 respectively. V2 is 2.02 volts and I2 is 70 microamperes. Take 12 readings for 12 different power supply outputs and fill out this data table. So what next? What next is with data table, you will draw a voltage versus a current graph using tracker software. To do this, click the View section and select Data Tool Analyze. Click the file on the Data Tool window and select New tab. Click New column. Enter the column name as I and then click OK button. Click New column again and name as V and then click button again. Current values should be on the horizontal axis. Now, the voltage and current data should be recorded in the data table. V1 is 1.00 and I1 is 35 microamperes. Enter the values and press Enter on the keyboard. V2 and I2 2.02 and 70. When you enter the values, spot over here. All data should be entered in this way. Fortunately, I've entered and saved this data for you before. Don't forget that this data has been collected as an example, so you will work different data sets. After the data entry is finished, click the Analyze section and select the curve fits to plot the baseline. The slope of the baseline gives you the value of the resistance due to Ohm's law. V is equal to R minus I. So R value is equal to A parameter, which is 3.006 times 10 to minus 2. So this is going to be experimental value of R. You should record this value with proper unit on the table. But how can you find the error value in R, which is delta R? You will use this equation and try to calculate delta R. R value is the experimentally defined value of R. Delta V and delta I are your uncertainties in the voltage and current measurements. When you draw the baseline and the curve fitting on tracker will give you RMS value. This RMS value on this axis is going to be your delta V. over here, we have V and I on the tracker graph analyzing window. If you press this axis, there is going to be two options over here, and you can select I. As soon as you select I, this axis is going to be I, and this axis going to be V. And all the values will change. In that case, RMS value is going to be delta I. These V and I values are the maximum values in your data table. Whatever the maximum value on the data table V is going to be over there, over here. And whatever the maximum value of I is going to be over here. So once you put these values on the equation, you can calculate delta R. These steps complete the experimental part, but you'll still one column to fill out. As the last step, you will calculate the value of R and delta R again by using the color code on the resistor to finish the experiment.